Hello everyone, welcome to this lecture series on backtracking approaches. So we will start with the n queen problems in this video lecture series, and we will see upon what approach. So in a backtracking, with a backtracking concept there can be a multiple approach possible. So within this video lecture series we will start with a naive approach that you will see in different words, and what is the n-queen problems and how this naive approach that's supposed to for the backtracking will be utilized to solve the n-queen problems. Okay, so let's start with what is the n-queen problem. So now this all those who are chess players, this is 8 cross 8 chessboards. There's 8 rows and 8 columns, so this will be 8 queen problems. If we have a chess of n cross n, it is a two-dimensional matrix with row and column, then we have n queen problems. So now our task is to place the queen, total 8 queen, in this chessboard. Now there are different particular pieces in the chess. Within that, one of the powerful is the queen, because it can go to, let's consider if I will put queen here. Let's say one queen will be here. Now this particular queen can go to this particular row, even go to particular column, and it can go to particular diagonal. So now if let me use another queen with the different colors. So consider my second queen will be here, or other queen will be here. So this queen can go to this particular row anywhere, this particular row, this particular column, again this particular column, this particular diagonal, anywhere, even this particular diagonal, and this particular diagonal, and this particular diagonal. So this queen can be going either of that way. Now let's say if I'm going to put another queen, for example here, if I'm going to put another queen, now straight away this queen will be attacked by this particular queen. Yeah? So we can see that this particular queen is going to attack this particular queen. So we have to put total 8 queens in this particular chessboard such a way that no queen is going to attack any other queens. None of the remaining 7 queens will become in any of the path of that queen. Now it is very straightforward. We have to put queens one in a one row. In each row we can only put one particular queen. We cannot put 2 queens in one row. That is what the heart of this kind of algorithm of backtracking, the naive approach, that in each row if we can put one queen only, then we may be able to find solutions. That is possible. So we start with first, second, third and fourth, one by one queen we are going to put. We will check whether that we arrived at the solutions. It means, do we have put all the 8 queens? If the 8 queen will be placed successfully with no any kind of attack to the remaining 7 queens, then we will arrive at our solutions. Now one questions, those who are chess players, what the importance of these numbers? A B C D E F G H 1 to 8, here also A B C D E H 1 to 8. Yeah. Now if there are 2 players playing the game, this number might not be important. They only require this particular chessboard, they don't require these numbers. Then why, if you take any printed kind of board of a chess, then every chessboard comes with these numbers? Okay, the answer is that generally we also want to follow the steps that was taken by kind of bigger competitions of a chess. Those who are chess players, like in India we have Vishwanath ji, in that we want to know that what moves that they are playing while they are in the kind of any competitions of a world level, and from that steps we want to learn a different strategy in a chess playing. So at that time those 2 players who have played the chess, they will recommend write down the words, okay, from A3 to B5, or from these to these, that they have kind of take the steps. So that will take us to the reiterate those particular steps. Even we don't require to see the video of that particular competitions, just we require is the steps. So let's say particular, let's say one piece will be here, and that I will write down the second thing. This is my B, so B3, and this is what I am write down, this D2. So from the B3 to D2. So I know that whatever piece that is here in B3, in that move the player moved from the B3 the D2. That is what the thing. So only we require is B3 and D2. That's all, our task is done. So this is the way the things will work out. On the both the ways you can try to take. If I am playing from this side, I will look out this thing. If I am playing from this side, I will look out from this point. So in both the point I am able to get it. Yeah. So look at the first approach. Of course the complexity is here in terms of there are total 8 for loops. For each particular row we have to use the for loops. Now in 8 queen we have 8 rows, so that's why we require 8 for loops that is required, and this is a particular solution that we may write. Now either it can be the solution that we wanted or it cannot be. If one of the queen will be attacked by any other queens, it won't be our solutions. Otherwise, if that is the solution, we are going to print the solutions and then we can stop. Now if we don't write this particular word, then what it means, consider that if we don't write this particular line, then it means this algorithm will print all the possible solutions of 8 queen problems. That is what the advantage of this algorithms. But the complexity of, if we have n queens, then we require n for loops, and all the for loops we go from 1 to n. So ultimately the complexity will be n raised to n. So you can see backtracking will give you the solutions, that is guaranteed. But the problem is time. The time will be much more in the backtracking. Yeah? That is what you can look at it out. So this is tester. It means here I3, I4, I5, I6, I7, I8 all will be try to utilize here, and then you have to check it out whether the particular this solution vector is actually our solutions. If it is solutions, you are going to print, otherwise stop it out. So let's take our again graph of this 8 cross 8. Now you can see that I have put you for this what is I1, I2, I3, I4, I5, 6. So the I1 queen will be going to be move on here, I2 will be here, I3, I4, I5, then the I6 will be in the 6th row, I7 will be in the 7th row, and I8 will be in the 8th row. So now let's see how the algorithm will start. So algorithm start will move, put the first queen here in the first, then the second queen again they will, because we are again start from the 1, so that's it, again start with the putting first here, then third, fourth, fifth, and the 6th, 7th, and 8th. So now this will be our first solutions that we are going to check whether it is actually our solution that we wanted. No, because this particular one queen, let's say this queen I will take it, this particular queen will be attacked by all the 7 queens. It means this is not our solutions. So now what it will do, clear, it will take now this queen other than apart from 1, it will again put it 2, again it is not, again it is not. So again the most 4 inner loop that is going to be executed now anywhere, because this is not the solutions anyhow. So now if this task is over, again it will this thing that will put it here, okay, again it will start from here, 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 so and so on. So again go it backtrack, again go it backtrack, again go it backtrack, so and so on, so and so on. So that's why it will ultimately try to see all possible combination of 1 to 8 and check it out whether do we have a solution possible. If it is yes, it is going to be print. So now that is what the advantage of backtracking, that backtracking will give you all possible solutions. Now the second puzzle in this particular chess problem, if I am going to ask the questions is my number of solutions is odd or even of this 8 queen problems. Without looking how many, only concern is what is it is odd numbers or even numbers. Then the answer will be even numbers, because if you have a one particular solutions of a chessboard, what you can do is you can take the mirror image of that solutions and you have the answers. So that's why in any of the chess problems you have a even number of solutions that is possible of any, either 8 queen, you can take 9 queen, 10 queen, up to any queens. So if you have a solutions available, it is in terms of even numbers. That is what it is. So let's try to take it one possible solutions of 8 queens. Now you can see this is the 8 queen. So total 8 queen will be placed in such a way that it is not going to be attacked. So let's try it out with first queen. Now this queen that we can show that this queen is going this way. This queen is going this way, in this way. Again the diagonal and that particular thing. So wow, no any queens will be attacked in this particular queen. Now let's try to go with the second queen. So we'll try to change the color. Let's take the second queen. Second queen will be going this particular way, this particular way, now this particular way, again this particular way. Yes, there is yet no any particular queens. Wow, in the even diagonal, no any queen available. Let's say in for example of for example the last queens against this particular way, no one's, no one's, no one's. Yep, against. Okay, let me try to erase this one. We will take, okay, this particular part. Wow, there is no any queen in between. So it means in general there is no any queen that is going to be attacked by any other queen. Now this is what our I1 to I8. So now what will be my solutions vector in this case? Yeah, so that is the solution vectors. I will look at the numbers of I1. So whenever I1 will reach to 7, I2 will be, I1 will be reached to 4, I2 will be reached to 7, I3 3, I4 will be 8, I5 will be 2, I6 will be 5, I7 will be 8, and I8 will be 6. In that case we got the solutions. So this is one of our solutions vectors. If we take, you can say, the mirror copy of this particular solutions, then we can get the second solutions. So that is what the word is that. That's why in a chess problem, this n queen problems, the number of solutions are always even. They won't be odd numbers. Yeah, so this is one particular way of using a backtracking for a n queens. Yeah, there may be a certain problems in particular this approach. There will be a more enhanced approach, so and so. So that will become in the upcoming video lecture series. Ultimately, this lecture will tell you what is the n-queen problem and then what is the simple approach that you can try to get all particular answers of the problems. Okay. Thank you, everyone.